So delta W will be equal to delta F into D. Now we have the slice of water which is at distance x, and this total height will be, so we are starting from -2. The cylinder is sphere is up to 2, then we have 1 more meter again, so there is a total of 3 meters. So from x the water must go up to 3, this 3, then from there it will go out. So d will be equal to 3 minus x, so we'll get delta W equal to delta F. So delta F will be 9800 pi 4 minus x square delta x into d will be 3 minus x. And now this is for one such piece. Now we need to integrate this from minus 2 to 2. Now x can be any value from minus 2 to 2, so that will give us integral minus 2 to 2 9800 pi 4 minus x square into 3 minus x dx will come. So that will be the required integral. So minus 2, we'll have minus 2 less than or equal to x less than or equal to 2. So therefore work done will be equal to, so we will have integral minus 2 to 2 9800 pi 4 minus x square into 3 minus x dx will come. So this will be the required integral for work done. Question number 5, we are given the points P, Q, R. Then we need to find the angle theta between the vectors A equal to PQ and B equal to PR. So A will be equal to PQ. So that will be coordinates of Q minus coordinates of P. So the vector PQ will be 2 minus 1 will be 1. So 1i. Then minus 2 minus minus 3. So that will be again 1j. Then minus 1, so that will be minus 2k. So that will be I plus j minus 2k, and vector b will be PR, so that will be coordinate of r minus coordinate of p. So minus 2 minus 1 will be minus 3i, then minus 3 minus minus 3, that will be 0j, and 4 minus 1 will be 3k. So that will be the coordinates of B. Now we need to find the angle theta. So A dot B will be equal to, so if you have two vectors, then the dot product will be equal to norm of A, modulus of A, modulus of B into cos theta. So we'll get cos theta equal to A dot B by mod A mod B. So A dot B will be equal to, multiplying the I components together, we will get minus 3. Its A component value will be 0. Then we will get minus 6. Now modulus of A will be root of 1 square, which is 1 plus 1 square, plus minus 2 square will be 4 into root of, here we will get 9 plus 9. So cos theta will be equal to minus 9 by root 6 into root 18. So therefore theta will be equal to cos inverse of minus 9 by root 6 into root 18. So that will be the value of theta. Now using this we need to find the area of triangle PQR. Now if we have two sides and an angle is given, then the area will be equal to length of PQ into, so that will be length of PQ, or that will be equal to mod A into mod B, then sine theta by 2. So this will be the area. Now modulus of A will be root 6, modulus of B will be root 18, by 2 into sine of cos inverse of minus 9 by root 6 root 18 will come. Okay. So that will be equal to, so here we'll get root 6 into, now 18 will be root 6 into root 3 by 2, so we'll get 6 by 2, which is 3, so that will be 3 root 3 sine cos inverse of minus 9 by root 6 into root 18. So that will be the required area. Next one, we need to find the linear equation of the plane that passes through the points P, Q and R. So we already have the vector PQ and PR. Now we'll calculate the cross product, that will be N. So N will be PQ cross PR, and the required equation will be x minus x naught, y minus y naught, z minus z naught dot n equal to 0. So this will be the normal vector to the plane. So this dot product will be equal to 0, and here x naught, y naught, z naught will be the coordinates of P. So let us first calculate n, which is PQ cross PR. So we'll get I, J, K, and components of PQ will be 1, 1, minus 2, and components of PR will be minus 3, 0, 3. So minus 3, 0, 3. So we'll get I into 3 will come, then minus J into 3 minus 6, which is minus 3, plus K into 0 minus minus 3. So we'll get 3. So that will be 3I plus 3J plus 3K. Now P will be, the coordinates of P will be 1 minus 3, 1. So therefore the equation of plane will be 3, 3, 3, which is n dot x minus x naught, so that will be x minus 1, y minus minus 3, so we'll get y plus 3, then z minus 1 equal to 0. So that will be 3x minus 1 plus 3, y plus 3 plus 3, z minus 1 equal to 0. So all 3 will cancel out, so we'll get x plus y plus z. Then we have minus 1 plus 3 minus 1, so that will be 3 minus 2, so plus 1 equal to 0. So this will be the required equation of the plane. Now we need to find the equation of line tangent to the curve x equal to sine t, y equal to t plus 1 whole square at the point t equal to 0. So equation of the line tangent r of t is given by c of t naught plus t minus t naught into c dash of t naught, where c of t will be the parametric representation of the curve. So that will be sine t t plus 1 whole square, and t naught will be the point t equal to 0. So 0 will be t naught. So this is c of t. So c dash of t will be cos t into 2 t plus 1. So c of 0 will be, so sine 0 is 0, and t plus 1 whole square at 0 will be 1, and c dash of 0 will be, now cos 0 will be 1, and here at 0 we will get 2. So therefore equation of line tangent will be r of t equal to 0, 1 plus t minus 0 will come, so that will be t into c dash of 0 will be 1, 2. So that will be 0, 1 plus t 2t, so that will be equal to t 1 plus t. So that will be the equation of line tangent. And next one, we need to find the area enclosed by one leaf of a graph r equal to 2 sine 5 theta. And now let us consider this particular leaf of the graph. Um, so if we have 5 theta equal to n pi, so 5 theta equal to n pi, in that case sine will be equal to 0. So we know that sine n pi will be equal to 0. So theta must be equal to n pi by 5. Now when n is equal to 0, we have theta equal to 0. So in that case sine will be 0. And when n is equal to 1, we have theta equal to pi by 5. So in that case, so if theta equal to pi by 5, here we'll be getting sine pi, that will be equal to 0. So in the first leaf, theta will be varying from 0 to pi by 5. So when theta is 0, we have sine 0, which is 0. And when theta equal to pi by 5, we have sine 5 into pi by 5, which is sine pi. So that will be 0. So in the first leaf, theta will be varying from 0 to pi by 5. So using this, let us find what is the area enclosed. So area is going to be equal to integral alpha to beta 1 by 2 r square d theta. So here for the first leaf, theta will be varying from 0 to pi by 5, that will be alpha and beta, and we will get 1 by 2 r square. So r square will be 2 sine 5 theta whole square d theta. So we will get integral 0 to pi by 5. So 2 square by 2 will be 2 sine square 5 theta d theta will come, and this will be equal to integral 0 to pi by 5. Now 2 sine square 5 theta will be equal to 2 sine square x will be 1 minus cos 2x. So this will be equal to 1 minus cos 10 theta. So we will get 1 minus cos 10 theta d theta. So upon integrating, we will get theta minus sine 10 theta by 10 from 0 to pi by 5. So for theta portion, we will get pi by 5 minus. Now sine 10 pi by 5 will be sine 2 pi, which is 0. Now at 0, all the values will be 0. So this will be the required area. So that will be the area. And for next part, we need to set up but do not evaluate an integral to find the length of boundary of one leaf of the graph. So we need to find what is the length of boundary of one leaf, or basically we need to find what is the length of the curve. So it is like finding the arc length. So length will be again given by integral alpha to beta root of r square plus dr by d theta whole square d theta. Now r will be 2 sine 5 theta, and dr by d theta will be 2 cos 5 theta into 5. So that will be 10 cos 5 theta. So this will be equal to integral 0 to pi by 5 root of, so r square will be 4 sine square 5 theta plus dr by d theta whole square will be, so we'll get 100 cos square 5 theta d theta. So that will be the integral giving length of boundary of one leaf of the graph. Now